Hello dear students, today I am going to show you a smart way to solve this JEE Mains optics question. So let us move on. Okay, so let us look at the question. The driver sitting inside a parked car is watching vehicles approaching from behind with the help of a side view mirror. So I've just given the convex mirror, a big convex mirror I have given, and there is a driver who is looking into this mirror. Of radius of curvature 2 meters. So this radius of curvature is 2 meters. Okay. Another car approaches him from behind with a uniform speed 90 kilometers per hour. So there is another car which is approaching from behind with 90 kilometers per hour. When the car is at a distance of 24 meters from him, okay, so when this car is at a distance of 24 meters from him, he sees the image inside this mirror. So he's seeing this image inside the mirror and he's asking us what is the acceleration of this image. So when this is at a distance 24 meters, what is the acceleration of the image inside the convex mirror which he's seeing. So first let us see the standard solution and then we'll see the smart solution. Okay, so let's move to the standard solution. So in the standard solution, initially we find the image distance, okay, and then the magnification, differentiate the mirror formula. After you differentiate it, then you again differentiate it to find the acceleration. So put all these values and finally you get the acceleration value. Okay, so this is the standard method. Let us move on to the smart method. Okay, so we have already seen the formula in the class that velocity of image, okay, equal to, just a minute, m, just a minute, m square velocity of object. Okay, the magnitude, there is a minus sign here. Now what we'll do is we'll directly differentiate this formula. So I can write acceleration of image equal to, now if I differentiate this I get 2m dm by dt, okay, into v0. Okay. Anyways, the velocity of object is constant, so this will remain as a constant like this. Now our job is to just find what is m and dm by dt. That's it. Okay. So what is the value of m? Tell me. See, here comes the smart move. Rather than writing m as in terms of v and u, we'll write it in terms of the known quantities. The known quantities are focal length by f minus. Okay, so we know that m is f by f minus u. So if I plug in these values here, what is f? R is 2 meters, so focal length is 1 meter. So I'll just put this here, 1 divided by 1 minus, so it is this side, 1 plus u is 24 meters. So we get this as 25. Okay, 1 by 25. Next, we need to find what is dm by dt. Okay, so dm by dt equal to, now if I differentiate this, what will I get? F by f minus u whole square, minus will come, okay, times du by dt, that is velocity of object. Okay. So just, what will be the value of this? Tell me. F is anyways 1. Okay, v naught 90 kilometers per hour, so that is nothing but 25 meters per second into 25 divided by, what is f minus u? F minus u is 25 square. Okay, so we have got the value of m and dm by dt. Now we'll just plug in these values here. So what is acceleration of image? Tell me. 2 times m is 1 by 25. dm by dt, again 25 gets cancelled. We get this also as 1 by 25 into, what is v naught? V naught is again 90, so that is 25. So what is acceleration of image? Equal to 2 by 25. He has asked the value of 100 times AI. Okay, so 100 times AI will be 8. The value of 100 times AI will be 8. Okay, so you see how in a very short manner we were able to solve this question. The difference between the standard solution and this solution is, see, in the standard solution, you're finding what is the value of V. Okay. You have again found what is the value of velocity of image. Position of image, velocity of image, you're finding out here. And that is why, more number of steps are coming here. And that we are eliminating here. We are not finding out position of image. We are neither finding out the velocity of image. We are directly moving on to the acceleration of image. Okay. So I hope you liked this smart way to solve a lengthy problem. Okay. So see you all. Bye bye.